Imagine a day like any other. The sun shines, birds sing, people go about their daily lives oblivious to the cosmic drama unfolding millions of miles away. Deep in space, a silent traveler heads towards Earth, a behemoth of rock and ice. This is not science fiction. This is our reality in a cosmic shooting gallery. The dinosaurs, wiped out by a similar visitor, remind us of our planet's vulnerability. But we have science. Our telescopes scan the cosmos, painting a humbling picture. We are one small planet in a vast universe. The vastness of space presents real dangers. Asteroids, the leftover building blocks of planets, hurtle through our neighborhood. Some pose an existential threat. The question is not if but when, and when it does, will we be ready? In the past few decades, we've gone from being passive passengers in the cosmic shooting gallery to becoming active guardians of our planet. We've built sophisticated telescopes with wide-field views, scanning the night sky for any telltale signs of movement that might betray the presence of a near-Earth object, or NEO. These telescopic sentinels are our first line of defense. They tirelessly scan the cosmos, looking for the faintest glimmer of light reflected off a potential intruder. It's a cosmic game of hide and seek, but the stakes couldn't be higher. Each point of light is carefully analyzed, its trajectory meticulously plotted. But finding these potential threats is no easy task. It's like looking for a needle in a haystack. Except, the haystack is the entire universe, and the needle is moving at thousands of miles per hour. Thankfully, we're getting better at it. Improved algorithms, coupled with the increasing power of our telescopes, are allowing us to detect and track smaller objects, giving us more time to react should we need to. Detecting a potential impactor is only half the battle. The real challenge lies in what we do with that information. Time, in this cosmic game of chess, is our most precious resource. The earlier we detect a threat, the more options we have for dealing with it. A small nudge to an asteroid's trajectory decades in advance could be enough to avert a collision with Earth. Wait too long, and that same nudge would require far greater energy, pushing the limits of our technological capabilities. Imagine this: a city-killer asteroid detected just months away from impact. Panic ensues. There's simply not enough time to mount a meaningful defense. The scenario underscores the urgency of early detection. The more warning we have, the better our chances of survival. It's a race against time, and the clock is always ticking. So, we've detected a large asteroid on a collision course with Earth. What do? Hollywood might have us believe in nuking it to smithereens, but in reality the solution is far more nuanced and elegant. One of the most promising strategies involves deflection. The idea is not to destroy the asteroid, but to gently nudge it off course, like a cosmic game of billiards. This could be achieved through a variety of methods, each with its own set of advantages and challenges. One such method involves using a kinetic impactor, essentially a high-speed spacecraft that crashes into the asteroid, imparting enough momentum to alter its trajectory. Another method involves using the sun's own energy to our advantage. By strategically painting one side of the asteroid with a reflective material, we can alter the amount of solar radiation it absorbs, subtly changing its course over time. These methods, while promising, are still in their infancy. They require significant technological advancements and rigorous testing before we can rely on them as viable planetary defense mechanisms. Section 5. United we stand, divided we fall. Global cooperation in the face of extinction. Facing a threat of this magnitude requires a unified global response. National borders become meaningless when the survival of our species is at stake. Cooperation, not competition, becomes the key to our continued existence. Imagine the complexities: deciding on the best course of action, pooling resources and coordinating the efforts of multiple nations, each with its own priorities and agendas. It's a daunting task, but one that we must be prepared for. History has shown us time and again that in the face of a common enemy, humanity can achieve extraordinary things. The International Space Station stands as a testament to our ability to overcome political differences and work together for a common goal. A planetary defense effort would require that same spirit of cooperation, but on a much larger scale. It would require a paradigm shift in international relations, a recognition that we are all part of one global civilization, sharing a common destiny. Section 6. Panic and Prudence. Human Reactions to Impending Doom. The news breaks: a planet-killer asteroid is hurtling towards Earth. How would we react? It's a question that has fascinated philosophers, scientists, and science fiction writers for centuries. Would we succumb to panic and chaos, or would we rise to the occasion, demonstrating remarkable resilience and ingenuity? The answer, like most things involving human nature, is likely a complex mix of both. There's no doubt that news of an impending impact would trigger widespread fear and anxiety. Denial, bargaining, anger, the stages of grief would play out on a global scale, but amidst the fear we would also witness extraordinary acts of courage, compassion, and selflessness. History has shown us that even in the darkest of times, the human spirit has an uncanny ability to shine through. We saw it in the aftermath of natural disasters, in the midst of war and famine. We saw it during the COVID-19 pandemic as communities came together to support one another. A planetary threat would undoubtedly test the limits of our resilience, but it would also reveal the very best of humanity. Section 7. The day the Earth trembled, immediate and long-term impacts. The day the asteroid hits, if it ever does, will be a day like no other in human history. The immediate impact would be catastrophic, unleashing an explosion millions of times more powerful than any nuclear weapon ever detonated. A shockwave would ripple across the planet, triggering earthquakes, tsunamis, and volcanic eruptions. The sky would darken as dust and debris are hurled into the atmosphere, blocking out the sun and plunging the Earth into a prolonged period of darkness and cold. But the devastation wouldn't end there. The long-term consequences of an impact would be equally dire. The impact would trigger a cascade of environmental effects, disrupting ecosystems, wiping out entire species, and potentially altering the course of evolution itself. The impact would also have profound implications for human civilization. The collapse of global infrastructure coupled with widespread famine and disease would pose an unprecedented challenge to our survival. It's a bleak picture, but one that we must confront head-on. By understanding the potential consequences of an impact, we can better prepare ourselves for the challenges ahead. Section 8. Rise from the ashes, technological readiness and post-impact recovery. Our technological prowess would be put to the ultimate test. Our ability to rebuild and innovate would determine our fate. The challenges would be immense. We would need to secure food, water, and rebuild infrastructure. Developing sustainable energy sources is crucial. Addressing long-term environmental consequences is vital. Mitigating future threats is essential. Amidst devastation, there are opportunities. Rebuilding would spark a new era of innovation. Advancements in agriculture, energy, and medicine. Surviving a global catastrophe could foster unity. The road to recovery would be long, but not impossible. Humans are resilient. We've faced challenges before, and we've always found a way to overcome them. An impact would be our greatest challenge yet, but with the right knowledge and preparation, we can overcome. Section 9. The weight of choice. Ethical dilemmas in a planetary crisis. The prospect of a planetary threat raises a host of ethical dilemmas that are as complex as they are profound. Who decides what we do? Who gets to survive? How do we allocate limited resources in the face of such a threat? These are not easy questions to answer. They force us to confront fundamental questions about the value of human life, the meaning of justice, and our responsibility to future generations. Do we prioritize saving as many lives as possible, even if it means sacrificing some for the sake of others? Do we focus on preserving our cultural heritage, or do we prioritize immediate survival needs? These are questions that we as a global society need to grapple with. We need to engage in open and honest dialogues about our values and priorities, and we need to develop ethical frameworks for guiding our decision-making in the face of such unprecedented challenges. Section 10. Scars on the soul, psychological resilience and mental health in the aftermath. The psychological toll of a major impact would be as significant as the physical devastation, the loss of loved ones, the destruction of homes and communities, the uncertainty of the future. These are all factors that could contribute to widespread trauma, anxiety, and despair. Addressing the mental health needs of survivors would be crucial to our long-term recovery. We would need to provide access to mental health services, create supportive communities, and foster a sense of hope and resilience. The arts and humanities would play a vital role in this process. Music, literature, and art have the power to help us process trauma, find meaning in chaos, and connect with one another on a deeper level. Section 11. Knowledge is power, education, innovation, and the future of planetary defense. Ultimately, Our best hope for surviving a major impact lies in our ability to prevent it from happening in the first place. This requires a sustained commitment to scientific research, technological innovation, and public education. We need to invest in the tools and technologies that will allow us to detect and deflect threats. We need to educate the public about the risks of asteroid impacts and the importance of supporting planetary defense efforts. But most importantly, we need to inspire the next generation of scientists, engineers, and leaders who will inherit this cosmic responsibility. We need to instill in them a sense of wonder about the universe, a passion for discovery, and a determination to protect our planet. The future of our species may very well depend on